Okay, so we are doing introduction to proofs. A two-column proof is the way we show things in geometry. A proof is an organized list of mathematical statements which are written in the left column. Along with reasons which we know the statement is true, which is written in the right column. Things that you can use to prove reasons include, so basically the left-hand side is going to be the mathematical statement, which is kind of like your work, okay? And then on the right-hand side is going to be your reasons. Why did you do that step? Things you can use to prove reasons are definitions, such as we've learned definition of a midpoint. We've learned what bisectors are, so like angle bisector. We could use segment bisector. We could use the word congruent. We learned what the word congruent means. We know what the word perpendicular means. You know what the word linear means. So there's lots of definitions that we've used. Postulates that we've learned. We've learned segment addition postulate. Or we've learned angle addition postulate. Not very nicely, but angle addition, segment addition, and then theorems that we've learned. We haven't done much with theorems yet, but an example of a theorem that you learned at some point would be like Pythagorean theorem. But we'll get more into theorems later on. So let's look at just some different types of properties. So we're going to skip the top box and go down here to some of these properties you've learned throughout middle school in doing one-step and two-step equations. For example, the addition, subtraction, multiplication, and division properties, these are ones that we use with equal signs. We used them in one-step equations, so like addition property is add the same number to both sides of an equal sign. So an example would be like if you had the problem x minus 2 equals 10, we learned to solve a one-step equation by adding 2 to both sides and getting x equals 12. Like we use all of these four in solving equations. So the subtraction property would be a subtract the same number to both sides of an equation. Again, an example of that might look like x plus 3 equals 7. And so you had to use the subtraction property to solve. By subtracting 3 to the other side, you would get x equals 4. So that was subtraction property. Okay, multiplication is multiply both sides of the equation by the same number. So example of that, let's say we have x over 5 equals 3. So an example would be to multiply both sides by 5 to get rid of the 5 on the bottom. So you get like x equals 15. These are just things that we've used in the past. Division would be to divide both sides of the equation by the same number. So like if you had 2x equals 12 and you want to solve for x, you learned that you should divide by 2. So that was the division property. The properties of equalities can only be used when you have an equal sign. Okay, we don't use these properties any other time unless we're going across the equal sign. So up here at the top, where it says properties of equalities only used when solving equations. Okay, so I'm just going to write add, subtract, multiply, or divide. Those are the 4 we use when we solve equations. Other properties that are listed at the bottom of your page here. One that should seem familiar is distributive property. When you distribute, you get A times B is AB, A times C would be AC. So with numbers, this is typically how it looks. 3 times x plus 4. When you distribute, you get 3x plus 12. Hey guys, I'm busy doing videos from home for you guys. Substitution property, if A equals B, then maybe A may be substituted by B in any expression. So we use this a lot, like we'll say if x equals 2, then if you have something like x plus 5, you would substitute the 2 in. So we would say 2 plus 5 is substitution, and that would equal 7. Alright, the last one on this page we're going to do is called the reflexive property. It says for any number, let me move this to the side here. For any number A equals A. Okay? So if 4 equals 4, it would just be, and we'll use that one later on,